Hey guys, it's Vince. Today in this video, we're going to be doing a little bit of a half a science project here, so to speak. I've done so many different videos discussing PDF manuals on grounding from Lincoln Electric.
Okay guys, I'm in the PDF manual from Lincoln that I've posted and done the overview on, covering grounding principles and also discussing EMI. In this actual excerpt that I'm about to read, I'm on page 20. And once again, for all of you out there, if you request this document, I do have it. I will gladly email it to you for free, whether you're a past client of mine or not. It's very good information to study and understand what you're getting involved with. Once again, we're going to be concentrating on this one paragraph right here where it's discussing earth electrode to earth resistance. The electrical resistance between the soil of the earth itself and the earth ground electrode, or also known as ground rod, determines the ability for the electrode to dissipate EMI. This resistance can be tested by a qualified electrical worker with the proper test equipment. It must be less than 25 ohms by code and should be less than 5 ohms for a shop with electronic CNC equipment. If the resistance is too great, additional earth electrodes may be needed. And you guys are going to see that in the experiment that I'm covering in this video because, again, it will easily show how easy it is if you have areas of your shop, like what's depicted here, where you may find it on the table. This area may be at one resistance level, and this area of the table may be at another. So again, please stay tuned for the rest of the video, and it'll all make sense. And I really hope that many of you will now understand what I mean by grounding your machine. And when we discuss it, it'll definitely define back and forth what you've done and what steps you've taken to make sure we're both discussing the same objective. Thank you.
Manual that I've actually provided. And again, Lincoln is a manufacturer of welding equipment, and of course they also deal with plasma cutting systems. Plasma systems, I've discussed this many times with many different past clients, potential clients, that they are in a league of their own when it comes to electromagnetic interference, or EMI. What I wanted to do is cover what is explained in that manual about using ground electrodes as far as grounding your equipment, and what we should be looking at when we say something in CNC, especially as the equipment is properly grounded. I've discussed with so many clients over the years grounding, proper technique, proper process, and usually when somebody has stability issues or problems with the system, I'll ask if a system is grounded. Of course, I get the email shot back to me, or they tell me straight up, you know what, I've done an excellent job grounding the system. Okay, well, that's going to remain to be seen after watching this, because there's never been a video like this. I've searched YouTube all over the place, and I've never seen anything like this, especially dealing with automation. If you read the Lincoln manual, Lincoln Electric explains that under code, and this is true for probably all states or damn close to all states, 25 ohms is what's considered to be acceptable for code for a ground electrode, also basically known as a ground rod. If you're dealing with telecommunications or CNC equipment, you're shooting for 5 ohms or under. Now, any of you familiar with electronics or electrical in general realize that's really low, guys. So what I've got here to do this little bit of experiment is just a 2.2K spindle. I've taken a piece of copper tape. I've taken half-inch tin braided copper, and I've soldered it to the copper tape. Okay, so again, we have the lowest possible resistance here. And why I'm using this spindle is because the spindle is going to be a representative of your CNC table. Now, I know many of you out there are saying, well, that's a motor. It really is kind of different as far as an actual CNC chassis. Well, in some respects, of course it is, because it's a motor. But if we take that out of the variables, really a CNC chassis is made up of a bunch of parts that are bolted together, and they're all usually metal. Under the best performance characteristics, they'd be metal. And therefore, you're going to have some conductiveness all the way through the chassis, if not all the way through the chassis, in order to properly ground the system. So what ends up happening is, typically, a client will say, well, I've got the chassis grounded because I have one point of ground and everything in the chassis is now perfectly grounded. And in theory, in his eyes and from what he would show, that is correct. Where the variance lies, and this is what's going to be interesting because you guys are going to see this live. What I've got here is a Fluke 179. Okay, I don't have to tell many of you the quality of a Fluke as far as being accurate. This is definitely going to be most likely one of the top 10 multimeters easily as far as giving us an accuracy ratio on continuity and, of course, looking at ohms. We're going to be utilizing this, and what we're going to do is I'm just going to cycle her on here over to our continuity rating. You can see we've got DL there. We've got our ohms symbol right here. Ohms, guys, for those of you that not know, I'm not going into rocket science here. We're going to keep it real basic, real simple. Ohms are basically resistance, electrical resistance. The lower the ohms, the faster we can dissipate any possible electromagnetic interference. We utilize shielded cables because shield, hence the word shield, is shielding the electronics and signals from any potential EMI. Well, if we keep our ohms low enough, then they're doing not only there to do their job, but you're making their job much easier. Okay? So that being said, we've got the meter on. You can see here if I touch the probes together, we're hitting 1 right on the money. Perfect. We got tone. Tone simply means that we have continuity. And what's interesting, and this is where this comes into play, and I've discussed this with many clients and potential clients, a lot of guys will notice right away that when they look at the spindle, I don't know if you can see that on camera, you look at the spindle's plug on the top, you may find on some manufacturers that they do not ground the actual spindle body. And the reason they don't ground the spindle body is because the manufacturer is assuming that your machine will have an aluminum or metal spindle mount, which will mount onto a metal CNC chassis. And once you ground the CNC chassis, I have a piece of 6061 right here, it has some holes drilled through it. We're just going to use this to prove we have continuity, which means it's conductive, guys. Okay, this is conductive material. Here we go. Dropping 2 right there. So when you guys have an aluminum chassis or aluminum spindle mount, again, the body is stainless, you are going to have conduction. Okay, so if you're properly grounded, this is where things get hairy. Once again, we're going to utilize this spindle. You can see if I touch the stainless body, we have continuity. Okay, just make sure my tips are on. There we go. We got 1 on continuity. Now, and when I say 1 on continuity, let me rephrase that. That's on your ohms rating. Okay, you see, if you move at all the tips, it's that sensitive, it will give you a variable. So we're at 1. We're going to touch it again. I'll put my hands down. There you go, 1. Now, what's interesting is we have metal inlets on top to actually circulate your fluid for cooling. Okay, down here we've got the chuck. It's also metal. Okay, what I'm going to do is I'm just going to insert one of the probes inside the actual inlet, the top inlet. There's one on the bottom and one on the top. I'm in the top inlet. And what I want to show you is, I'm going to just touch the body. We're at 1. Okay, continuity there is excellent. And we also have 1 on our ohms, so we know we're really low. If you actually built the machine and it was at 1, you're pretty much dead nuts on. Okay, what's interesting is, if I move to the other actual cooling inlet, just make sure I get this in there real quick. There we go. I'm just going to touch that again to the spindle body. You're at 1 once again. Once again, if your system was grounded at that level, you know you're golden because your ohms rating is so low. Okay. If, however, I leave this probe into this second inlet, which is underneath the first inlet on the top, and I decide to keep coming over here and checking, now we're at the copper tape and we're registering at 3, 4, 5, going back and forth. There it goes. So we're at 5 right there. Coming over, I'm at 1. There we go. 3. Now where it gets interesting is I'm going to come over here to where the chuck is, where it rotates, and just above where it rotates, you'll see there's milled grooves inside a spindle. Okay, and the milled groove inside the spindle is actually used, again, many of you know, for your wrench, so you can actually have a place to grab and it won't slide. I'm going to take a measurement right from there. I'm just going to move this out of the way for now. Okay, you guys can see we're at 16, 15, 14. I'm going to move back to the spindle body. Huge difference. Yet, the unit is conductive. And this is less than a foot. Okay. The question I have for you is, how do we level resistance? A very simple way of leveling resistance from a low end of the table, so to speak. Once again, this is to represent your table. And again, the reason I'm doing this is much smaller and easy for me to work as the same type of principles that would work with your chassis, being there's a bunch of parts bolted on and most of them are conductive. In this instance, it's the same principle. We have the chuck, we have the spindle's actual shaft, and take away the fact that it's a motor, it's a bunch of metal parts that are assembled together and they should all conduct. Well, they are conducting. But what's really interesting is you notice we're very low right here on the body itself, but yet as we come over here less than 12 inches away, we've got a much higher resistance. So in order to negate or level the resistance all the way across the board, we use some tin braided copper. And again, I've added just a band of copper tape, soldered the copper strap to it. And all I'm going to do, I'm going to show you this. I'm going to make contact right here. Now we're at 12. There's with the copper strap on there, and if I hold it to it, huge difference. Leave it on. Put the strap on, strap off, on, off. You guys now have a definitive example of how a small distance of a bunch of assembled metal parts can yield different results, even though, technically, it's grounded. So the key here is not looking at how something is just simply grounded, but looking at the table as an entity. It has to be grounded level. And when I say level, we're looking for an ohms actual level that should be 5 or under. That's telecommunications level, and anything under that, according to our spec from going from Lincoln, if that's certified for dealing with plasma systems, this is definitively going to make a huge difference on any system. Is there a lot of work involved with this? There could be, depending on how your shop is set up, how the machine is set up, what steps you've already taken preliminarily to actually get everything in place. But is it worthwhile? I definitively believe it will be more worthwhile than anything else you can invest in. Shielded cables are a must. If you do this, it's going to make their job 10 times easier. Okay, and everything in your shop that much easier. Now, as your shop gets larger, performing a task like this, where you're just, now in this instance, I'm just adding a copper strap, you guys can do this. If I want to actually reduce resistance even more, all I would have to do, and I've got another copper strap here, and this one's thinner, it's just been used a couple times. If I add this to this, and just apply it to the body, now I'm opening the flow of water even more, because now I have more surface area for conductive material. And if I touch this, we should see an even lower drop. There you go. Take it away. Put it back. You're within spec. Okay? That simple, guys. It's that simple to utilize this principle on your entire chassis. I've searched YouTube everywhere, never been a video on this. There's never been a video even discussing this, and yet the principles are the same regardless of a spindle, regardless of a chassis. Whatever is assembled in metal that you're trying to ground, it needs to be levelized. Look at it from doing it at a standardized level. Everything should be at that 5 ohms or under. Not just grounding, okay? My assumption, again, when I do videos, is I assume sometimes that everybody knows this, and that's my fault, and I'll admit that. I take full responsibility for that. But what I cannot take responsibility for is when someone says something is grounded, and if they say it's grounded, I'm assuming that they've done a ground rod, they've done ohm measurements to make sure that the machine is grounded. That's why I'm putting all the documentation in place so you guys have reference material, saving you thousands of dollars. Because the bottom line is, when the equipment is grounded properly, there's really no other force that could play with any of your signals, because your system is properly grounded and you're dissipating any excess energy, which is electromagnetic interference, and once again yielding that stability you're looking for. But it's just, this I feel really, really dictates just how sensitive, just checking the body here and then checking the body here, And you could see just a huge dramatic difference. A couple pieces of copper really make a big difference. That's how fast. You can utilize every principle I've done here at a larger scale for your own machine, and the results will be noticeable. Now, that being said, of course, if your machine is already stable, and many of you are saying, well, I'm not going to screw with my machine. It's stable. God bless you. That's wonderful. It doesn't mean that you won't use this information later on, because you've just spent however much time watching this video of your life, and I guarantee you this information will come in handy for whatever you're doing with electronics, especially in automation. Okay? Hopefully this video has been helpful to many of you. And again, I know I'm going to have more questions. This is not a definitive answer to every problem of stability. Again, there's many variables. I mean, it's still not going to correct natural hardware issues, wiring issues, problems with drives. There's nothing that's going to correct that. But if we're looking at grounding, whatever that may be, of course, a grounding rod, there are tools, Fluke makes many tools, that will actually measure the soil for its conduction as far as dissipating actual electromagnetic interference or RF. Whatever you're looking at, there's basically a tool out now for that. Now, of course, that's like $4,000. Most of your good, high-quality, code-related electricians will have access to a tool like that. This is why I recommend when you're setting your machine up, if you're in a shop, in a commercial environment, it's worth it to have them go and check everything, because it's going to definitively carry over into the rest of the system. I think you've really seen this now, and it all really makes sense, and it really shows just how simple this is. It doesn't have to be that complex, but I can tell you right now, very seldom will you have a machine be grounded at the same level of ohms all the way across. There's always going to be different areas that may be grounded, may not be. You may have insulated areas where certain areas are non-conductive, and this is a good point too. You can see this black area on the spindle. If I touch here, we're not getting a reading, meaning it's non-conductive. If I touch here on the body, we do. So let's just say this was where your bearing is, and maybe your bearing block is coated. Okay, if it's coated, you're not going to get a reading, but here you will. So again, there's variables you have to deal with, and you guys go through your systems and you'll familiarize yourself with the chassis. But if you can get it to that level, if you take that level of detail and apply that in your chassis, I am telling you now, many of you will be very, very happy with the outcome. So again, I hope this video has been helpful. I will be putting an actual, you've probably already seen it earlier in the video, I'm going to cut and paste an actual excerpt from the Lincoln manual describing exactly what I'm talking about. Again, I was under the assumption many of you have looked at it, reviewed it, and understood that. The more I get into definitive details about this, then that aha moment comes into where people are like, well, I didn't do that. The other factor I cannot point out enough, get quality tools, guys. When we're measuring stuff like this, I've got a Klein here. I've got this, and I've had this for years, and I can tell you right now, this has cost me about $100, $125, I think, with tax, whatever it may be. I've had this for quite some time. This unit is not even close to a Fluke. There is no comparison. When we're talking about measuring the system for stability, which is essentially what we're doing when we're actually measuring our ohms rating for resistance for ground, you definitely want to have the right equipment. And I cannot emphasize enough, investing in a Fluke or another unit, you can get a lower, one of the lower quality Flukes, I should say it that way. It's more like a novice level Fluke. Is probably going to run you like $100. The 179, it's like $500. You can get them online for about $300. You can buy them used for $250. These are what you really want to use when you're taking these kinds of tests. So your continuity levels are going to be the same all the way across. You don't have to second guess the equipment. This equipment with the Klein, I second guess. So that's why I'm telling you, when you have to do stuff like this, it will pay itself off in a stable system. And many of you know what that means to you and your business. So again, I hope the video has been helpful. If you guys do have questions, and I know it's going to raise more questions, it just always does, message me direct at storm2313@gmail.com. That is my personal email. And I will also put Link in the description to my eDealer Direct store, eDealers Automation. And in this way, if you guys need to get in touch with me, you can get in touch with me direct. Now, please keep in mind, this is peak season. The shop is getting busier. I'm not being disrespectful to anyone. I will get in touch with everyone as soon as possible. I strive to get in touch with everybody within a couple hours. But again, as I get busier, it makes it much harder to do that. So please understand that. Thank you all for your support. My subscribers, I love you. Take care.